It is 2101. So first of all, before going into the presentation, we need to understand what actually are high efficiency batteries. So generally, the high efficiency batteries are the one that are used for storing the energy, and they also used for releasing the energy when required. So it will be used in various applications like electrical vehicles, renewable energy systems, and also portable electronics and various other things. These batteries are designed in such a way that they will be giving a lot of energy with a minimum energy loss so that it can be used for sustainable future. So the efficiency of these batteries are derived by various factors, like it is mentioned in the PPT, like energy density, charge and discharge life cycle, thermal stability, and internal resistance, etc. So when we try to enhance these properties with enhancement of these properties, the battery efficiency will also increase. So today mainly we'll be discussing about two main type of batteries, that is the lithium ion battery and the lead acid batteries. Coming to lithium ion batteries, they are very lightweight and they can be rechargeable and have high energy density. So these are used mainly in some applications like electronics, electrical vehicles, and also energy storage systems. And when it comes to the lead acid batteries, these are very less expensive and have a longer lifespan. They can be used for longer times when compared to the lithium ion batteries. So the applications of lead acid batteries includes automobiles, backup power systems, and industrial applications. So first, we need to understand how the functionality and what all the common components that are present in a high efficiency batteries. As mentioned, we can see anode, cathode, electrolyte, and a separator. Anode is an electrode which is negatively charged and where the oxidation occurs. When it comes to cathode, it is a positive electrode where reduction occurs. And electrolyte is a conductive medium where there is a movement of ion and electrons in order to perform the chemical reactions. And there is a separator to prevent direct contact. Uh, so now we'll be going into the components of lithium ion battery. In the lithium ion battery, the anode is made up of a graphite material, and the cathode is made up of the metal oxides of lithium, like lithium cobalt oxide, etc. So here the electrolyte we use is lithium salts, which is in a solvent, and the separator is made up of a porous materials like propylene. So the overall reaction that is used in the lithium ion battery is mentioned. So any battery, there are two things, that is a charging and discharging. Charging is where we store the energy, and discharging is where we use the stored energy for our various applications or various purposes. So as mentioned here in the discharging, first the oxidation occurs at the anode where the Li6 will be split into Li++ electrons, giving out the electrons, and at the cathode, the reduction happens where the Li will take the electrons, forming a compound. When it comes to the charging, at anode, the reduction happens, it forming a compound called Li(C6), and at the cathode, the compound is broken down, releasing the electrons. So this is the overall reactions that would take place in charging and discharging of lithium ion batteries. So what are the advantages of lithium ion batteries? They are having high energy density. They are lightweight and having a good design. They'll be having a longer cycle of lifespan, like it can be used for a long time. And they are environmentally friendly, like they'll be releasing less chemicals or pollutants into the environment. And what are the limitations of the lithium ion battery? Here, safety concern. There could be a possibility of fire hazard or overheating by using these batteries, and they are a little bit high cost when compared to the lead acid batteries. There is also a performance issue which is degraded when the temperature is very high. So these are all the applications of lithium ion batteries, like it can be used in smartphones, tablets, smartwatches, wireless earbuds and Bluetooth, digital camera, drones, electric cars, and all the other things like solar power storage systems, wind energy, home and industrial battery, and all these are applications of lithium ion batteries. Now we'll be going to dive deep into lead acid batteries, which includes charging and discharging, as have been mentioned before. So in the charging process, the lead sulfate is converted to lead oxide and as well as lead. And during the discharging process, these two compounds, that is the lead oxide and lead, are converted and combined to form lead sulfate. See, so these are the possible reactions that are being happened in the lead acid batteries. So, so in the discharging process, at the anode, lead and sulfate combine to form lead sulfate plus also releasing the electrons. And at the cathode, the reduction happens. That is, the lead oxide combines with sulfate and also electrons, forming the lead sulfate. So in the charging, at the anode, the reduction happens. The lead sulfate is broken down into lead and sulfate ions. And at the cathode, oxidation happens, where the lead sulfate reacts with water to form lead oxide and also sulfate, and also releasing the electrons. These are all the possible reactions during the discharging and charging processes in lead acid batteries. So these are the advantages of lead acid batteries, where they are cost effective. As already mentioned, they are little lower cost when compared to lithium ion batteries, and these will be having a longer lifespan, like it can be used for a very long time, and they are very reliable, like it will be having a good performance. When it comes to the limitations of lead acid batteries, they are little heavy, so it will be difficult to handle, and they are having a low energy density. So only it will be having a limited energy storage capacity, and due to this, as the lead is a very toxic metal, there are environmental concerns, where we can see in the lithium ion batteries there are less environmental concern when compared to lead acid batteries. So these are all the applications of lead acid batteries, like it can be used in automobiles, lighting, ignition, inverters, where we use it in home and also in industrial purposes, and also uninterruptible power supplies, when like we can see when in our home, when there is no power, then also we'll be able to use it, that is UPS. And also in the telecommunications and various electrical vehicles like wheelchairs and mobility scooters, golf carts, marine applications, like whatever we use in sea, submarines and boats. Also in the railway systems, like lightning and signaling, where the trains can communicate, like which train to go first, etc. And also in aviation, where aircrafts are used, like flights, etc. So these are all the applications of lead acid batteries. So this is presentation from my side. So thanks.
Okay. Next, 528.